long before there were people, before there were mammals, before there were even hearts as we know them, life was already moving. Not moving with intention, not moving with awareness, but moving in a way that kept itself going. The story of the human heart does not begin in the chest. It begins in water. Billions of years ago, the earliest living things were simple. Single cells floating quietly in ancient oceans. They did not need hearts. Their surroundings did most of the work for them. Oxygen, nutrients, and waste moved in and out by simple diffusion. Life was small enough that nothing needed to be pushed very far. But as life grew more complex, distance began to matter. Cells grouped together, bodies became thicker, layers formed, and suddenly, relying on the surrounding water was no longer enough. What was inside needed help reaching what was deeper within. This is where the idea of circulation first appeared, not as an organ, not as a structure, but as movement. Some early organisms developed gentle internal currents. Fluids moved slowly through simple channels, nudged by the motion of the body itself. There was no heartbeat yet, no rhythm, just flow. This flow was enough for a long time. As bodies became more complex, this internal movement needed to become more reliable. Passive flow turned into directed flow. Channels became more defined, and eventually, certain regions began to contract, not with force, not with strength, but with regularity, a simple squeeze. That squeeze is the ancestor of every heartbeat that followed. In early multicellular animals, this contraction wasn't centralized. It didn't come from one place. It was more like a wave passing through soft tissue, gently moving fluid along. The body learned that rhythm mattered more than power. A steady push was better than an occasional strong one. Over time, evolution favored organisms that could move internal fluids efficiently. Those that could deliver oxygen and nutrients a little faster survived longer, grew larger, and reproduced more reliably. Slowly, the contractile tissue became more specialized. Instead of squeezing everywhere, it began to squeeze in one place. A primitive heart was forming. These early hearts were simple tubes, long, soft structures that contracted from one end to the other, pushing fluid forward in a single direction. There were no chambers, no valves, just rhythm and direction, but this was enough to change everything. With a dedicated pumping structure, bodies could grow larger. Tissues could specialize. Movement could become more controlled. Life could begin to explore land, air, and new environments that demanded more from circulation. Even at this early stage, the heart was not about emotion or symbolism. It was about continuity, about making sure that every part of the body received what it needed, again and again, without pause. The heart learned one lesson very early in its evolution. It did not need to think. It did not need to decide. It only needed to continue. As life diversified, different solutions emerged. In some creatures, the heart remained simple. In others, it began to divide. Chambers formed to separate oxygen-rich blood from oxygen-poor blood. Valves appeared to prevent backflow. Efficiency increased. Each change was small. Each change took millions of years. Nothing was rushed. Fish developed hearts with 2 chambers, perfectly suited for life in water. Amphibians followed, bridging the gap between aquatic and terrestrial life, their hearts becoming more flexible, more adaptable. Reptiles refined this further, supporting longer periods of activity and varied temperatures. Then came a turning point: warm-blooded life. With mammals and birds, the heart underwent one of its most important evolutionary shifts. 4 chambers, complete separation. Oxygen-rich blood delivered efficiently to support constant internal temperature and sustained activity. This was not about speed. It was about endurance. The heart evolved not to beat harder, but to beat smarter, to maintain rhythm over long periods, to support lives that moved, rested, hunted, nurtured, and slept with consistency. By the time humans appeared, the heart was already ancient. It had been shaped by oceans, land, cold nights, long migrations, and quiet rest. It had learned how to adapt to stress and recover during calm. It had learned how to keep going without instruction. The human heart did not evolve for modern life. It evolved for continuity. It is a solution refined over hundreds of millions of years, still doing the same quiet work it always has. Contract, release, move life forward. And in the next part of this story, we'll slow down even further. We'll look at how chambers formed, how rhythm became precise, and how the heart learned to coordinate with breath, movement, and time itself. As the heart became more defined, its evolution began to focus less on creating force and more on creating order. A simple tube that squeezed fluid forward was enough for early life. But as bodies grew more complex, the timing of that squeeze started to matter just as much as the squeeze itself. Blood needed to move in one direction at the right moment without slipping backward. This is when separation began. Inside those early hearts, gentle folds of tissue formed. At first, they didn't divide anything completely. They simply guided flow, nudging blood along preferred paths. Over time, these folds became more pronounced, shaping chambers that could fill, empty, and refill with greater precision. This was not a sudden redesign. It was a refinement. Evolution rarely replaces what works. It layers improvements on top of it. The heart kept its original purpose and slowly added structure around it, the way a river carves channels without losing its flow. As chambers emerged, the heart gained a new ability. It could pause, not stop, but separate movement into phases. Filling and pushing became distinct moments rather than a single continuous squeeze. This separation allowed blood to move more efficiently, even as bodies became thicker and more demanding. Valves appeared next. At first, they were simple flaps of tissue. Soft, flexible, responsive. They didn't open and close with authority. They responded to pressure, yielding gently when blood pushed forward and settling back when it tried to return. Valves did not create rhythm. They protected it. They ensured that each contraction moved life forward, not backward. This one-way flow reduced wasted effort and conserved energy, something evolution always favors. As hearts became more chambered, they also became more reliable. Fish, living in water where oxygen is absorbed through gills, developed a 2-chambered heart. One chamber to receive blood, one to send it onward. Simple, efficient, perfect for an environment where buoyancy supported the body and gravity was less demanding. But when life began to explore land, everything changed. Gravity mattered. Air behaved differently than water. Movement required more energy. Amphibians were among the first to bridge these worlds. Their hearts reflected this transition. 3 chambers instead of 2. A partial separation that allowed some mixing of oxygen-rich and oxygen-poor blood, but enough control to support both aquatic and terrestrial life. This design wasn't perfect, but it was adaptable. Adaptation, not perfection, is what evolution rewards. Reptiles refined this further. Their hearts allowed for more controlled separation. supporting longer periods of activity and more varied environments. Blood flow could be adjusted depending on whether the animal was resting, moving, or regulating temperature. The heart was no longer just a pump. It was becoming a coordinator. It learned to respond to the body's needs without conscious control. Activity increased flow. Rest reduced it. Temperature, posture, and effort all shaped how the heart behaved. All of this happened without thought. There was no brain directing these changes in real time. The heart learned through structure, through built-in pathways that responded automatically to pressure, stretch, and rhythm. This automatic nature is one of the heart's greatest evolutionary achievements. Long before complex brains evolved, the heart already knew how to adjust. It could speed up, slow down, and redistribute flow based on the body's state. It didn't need awareness to do this. It needed only consistency. As chambers and valves became more precise, the heart's rhythm became steadier, less variable, more dependable. This reliability allowed animals to move longer distances, remain active for extended periods, and recover more quickly. And as activity increased, so did the need for coordination. Breathing and heartbeat began to align. In early organisms, these systems were loosely connected. Over time, they became tightly coupled. The heart learned to respond to oxygen demand, adjusting its pace to match respiration. This coordination laid the foundation for endurance. Not speed, not power, but the ability to keep going. By the time warm-blooded animals began to emerge, the heart was already prepared for its next transformation. One that would demand even greater precision, even greater separation, and an unwavering commitment to rhythm. That transformation would change not just how the heart worked, but how life itself was lived. As warm-blooded life began to take shape, the heart faced a new kind of challenge. Until now, circulation had supported bodies that changed with their environment. Activity rose and fell with temperature. Rest followed cold. Energy was conserved naturally. The heart adapted to these rhythms without needing to maintain constant output. Warm-blooded animals changed that arrangement. They carried their environment inside them. To keep internal temperature stable, the body needed a steady supply of oxygen and nutrients, regardless of external conditions. Muscles could no longer wait for warmth. Organs could no longer slow down simply because the world outside was cold. The heart had to become unwavering. This is where one of the most important evolutionary refinements occurred. Complete separation. In mammals and birds, the heart divided fully into 4 chambers: 2 to receive blood, 2 to send it onward. Oxygen-poor blood returning from the body was kept entirely separate from oxygen-rich blood coming from the lungs. This separation was not about complexity for its own sake. It was about efficiency without confusion. With 4 chambers, the heart could manage 2 circuits at once. One sending blood to the lungs to receive oxygen. The other sending freshly oxygenated blood to the rest of the body. Each circuit could operate at its own pressure, its own pace, without interference. This allowed for sustained activity. Endurance became possible in a new way. Animals could remain active for long periods, hunt patiently, migrate over great distances, and care for offspring without needing long pauses to recover. The heart supported this lifestyle by becoming exceptionally reliable. It did not need to beat harder. It needed to beat consistently. This consistency required something more than muscle. It required timing. Within the heart, specialized tissue emerged that could generate and conduct electrical signals. These signals coordinated contraction so that chambers filled and emptied in the correct order every time. This electrical system was not designed for thinking. It was designed for trust. Once established, it allowed the heart to beat without instruction, without interruption, without fatigue. Even as the brain slept, the heart continued its rhythm, guided by signals refined over millions of years. The beauty of this system lies in its simplicity. A small group of cells sets the pace. Signals travel along defined pathways. Muscles respond. Valves open and close. Blood moves forward. Then the cycle repeats, again and again and again. This rhythm became the foundation for warm-blooded life. It allowed mammals to explore colder climates. It supported night activity. It made social behavior, extended parenting, and complex brains possible. The brain often gets credit for intelligence, but it relies completely on the heart's stability. Without steady circulation, there is no sustained thought. Without reliable rhythm, there is no memory. Without endurance, there is no learning. The heart made thinking possible by never stopping. As mammals diversified, their hearts adapted subtly to different lifestyles. Fast runners developed hearts that could increase output quickly. Swimmers developed hearts efficient at working against pressure. Climbers, diggers, and flyers all carried hearts shaped by their unique demands. But the core design remained the same: 4 chambers, one direction, unbroken rhythm. By the time early humans appeared, this design had already been tested across countless species and environments. It was not experimental. It was proven. The human heart inherited this ancient architecture fully formed, already capable of supporting long walks, sudden bursts of effort, deep rest, and extended wakefulness. It did not need to evolve new tricks for humanity. It needed only to continue. In the next part of this journey, we'll look more closely at how the heart learned to communicate with the rest of the body, how signals from muscles, lungs, and blood itself shaped heart rate and rhythm, allowing the heart to respond moment by moment without ever needing conscious control. As the heart structure became stable, evolution turned its attention to something more subtle: communication. A heart that could beat steadily was not enough on its own. It needed to listen, to sense what the body was doing, and adjust without being told. This ability to respond, rather than simply repeat, became one of the heart's most important evolutionary strengths. The heart learned to feel, not emotions, but information. Blood returning to the heart carries signals: changes in pressure, changes in volume, changes in chemistry. Oxygen levels rise and fall. Carbon dioxide accumulates. Temperature shifts. Each of these variations gently stretches the heart's walls or alters the environment inside them. The heart responds automatically. When muscles begin to work, they demand more oxygen. Blood returns faster. The heart feels this increased flow and responds by beating more quickly and more forcefully. When the body rests, blood returns more slowly. The heart eases its rhythm. This responsiveness does not require thought. It requires sensitivity. Specialized cells in the heart walls evolved to detect stretch. Others respond to chemical changes. These cells do not interpret information. They react to it. Their behavior is built into their structure. This is one of the reasons the heart feels so dependable. It does not wait for permission to adapt. It adapts because adaptation is what it is made for. As animals became more active and more complex, This responsiveness allowed the heart to coordinate with the rest of the body in increasingly refined ways. Heart rate rose smoothly with movement. It slowed gradually with rest. Sudden changes were buffered, softened, controlled. This smoothing effect protected the body. Rapid, uncontrolled shifts in circulation would be dangerous. Evolution favored hearts that could transition gently between states, not just fast or slow, but appropriately fast or slow. Breathing became a key partner in this process. As lungs evolved to support air breathing, the heart and lungs learned to synchronize. Inhalation changed pressure in the chest, subtly affecting blood flow. The heart adapted its rhythm to these changes, aligning beats with breath. This coordination improved efficiency. More oxygen could be delivered with less effort. Waste could be removed more reliably. Endurance increased without requiring more energy. Over millions of years, this relationship deepened. The heart began to vary its rhythm slightly with each breath. This variability was not a flaw. It was a sign of flexibility. A heart that could change moment by moment was better equipped to handle stress and recovery. This adaptability became especially important for mammals. Mammals did not live simple, repetitive lives. They moved unpredictably. They played, fought, nurtured, rested, and explored. Their hearts needed to support sudden changes without losing rhythm. The heart evolved to do exactly that. It learned to respond not just to physical demands, but to internal states. Hormones released during excitement, fear, or calm all influenced heart rate. The heart integrated these signals seamlessly, adjusting circulation to match the body's needs. Still, none of this involved conscious control. The heart's intelligence is structural, not cognitive. It does not analyze, it responds. This kind of intelligence is ancient. Long before brains could plan or reflect, the heart already knew how to match effort to need. It learned through countless generations what patterns worked best. Those patterns became embedded in tissue, pathways, and reflexes. By the time humans emerged, the heart was already deeply integrated into the body's regulatory systems. It worked with the lungs, the blood vessels, the muscles, and the nervous system as part of a single, coordinated network. A network designed not for extremes, but for balance. In the next part, we'll move even closer to the human story. We'll explore how the heart supported long walks, endurance, and recovery, and how its ancient rhythms shaped the way early humans lived, traveled, and rested across changing landscapes. As humans began to take shape, the heart entered a phase of evolution defined not by speed, but by distance. Early humans did not rely on sudden bursts of power. They relied on persistence. Long walks across open land, hours of movement under changing skies. The ability to keep going, not quickly, but steadily. The heart adapted to this way of living quietly. Its rhythm became tuned for endurance. Not racing, not straining, but maintaining a pace that could last for hours. Blood flow supported muscles that worked continuously rather than explosively. Oxygen delivery favored efficiency over intensity. This endurance-based design shaped much of human physiology. Compared to many animals, humans are not exceptionally fast. We are not especially strong. But we are remarkably capable of sustained effort. The heart made this possible by learning how to balance output and recovery over long periods of time. When early humans walked, the heart responded gradually. When they rested, it slowed smoothly. There were no abrupt shifts. This smoothness protected the body from exhaustion. It also supported something else that was becoming increasingly important: the brain. As human brains grew larger and more complex, they demanded a constant and reliable blood supply. Unlike muscles, the brain cannot tolerate interruption. It requires steady oxygen delivery, even during rest. The heart met this demand without complaint. It continued its rhythm through sleep, through stillness, through long periods of minimal movement. While the body rested, the brain remained active, consolidating memory, regulating emotion, and preparing for the next day. This required trust. The brain trusted the heart to continue without supervision. The heart trusted its own structure to adapt as needed. This partnership became one of the defining features of human biology. Human social life also shaped the heart's evolution indirectly. Living in groups meant coordinating movement, sharing effort, and responding to others. Emotional states began to influence physiology more strongly. Excitement, fear, calm, and connection all affected heart rate. The heart learned to respond to these internal signals, just as it responded to physical ones. When danger appeared, the heart accelerated, supporting alertness and readiness. When safety returned, it slowed, allowing recovery. When connection was present, rhythm softened. These responses were not conscious choices. They were reflexive patterns shaped by survival and cooperation. Over generations, hearts that could recover quickly after stress proved advantageous. They conserved energy. They reduced wear. They allowed individuals to remain resilient over long lives. This emphasis on recovery is an often overlooked part of heart evolution. The heart did not evolve only to respond to stress. It evolved to leave stress behind. Rest was as important as movement. Sleep as important as wakefulness. The heart supported both with equal commitment. As human environments changed, from open plains to shelters, from daylight movement to nighttime rest, the heart maintained its steady presence. It did not need to adapt to tools, language, or culture directly. It adapted by continuing to do what it had always done: respond, adjust, recover. By the time early civilizations formed, the human heart was already ancient and refined. It had supported countless generations through movement and stillness, effort and rest, danger and safety. And yet, its evolution did not stop. In the next part, we'll explore how the heart adapted to increasingly complex nervous systems, how signals from the brain began to shape heart rhythm in more nuanced ways, and how this connection deepened the relationship between thought, emotion, and circulation. As the human nervous system became more complex, the heart entered a new kind of relationship. For millions of years, the heart had responded mainly to physical signals: pressure, stretch, oxygen demand. These cues were immediate and concrete. They reflected what the body was doing in the present moment. But as brains grew larger and more socially attuned, another layer of information began to influence the heart: anticipation. The heart started responding not only to movement, but to expectation, not only to effort, but to meaning. The nervous system could signal danger before it arrived, or calm before movement stopped. This added nuance did not replace the heart's older systems. It layered itself gently on top. Signals from the brainstem and deeper regions of the nervous system began to modulate heart rhythm. They did not command the heart. They shaped its range. The heart learned to beat within a spectrum, adjusting moment by moment to both the body's state and the mind's interpretation of the world. This connection allowed the heart to prepare in advance. Before muscles moved, the heart could increase its pace. Before rest fully arrived, it could begin to slow. Before danger was physical, it could become alert. This anticipation improved survival. It allowed humans to respond quickly to threats, coordinate group movement, and adapt to changing environments with greater flexibility. The heart became part of a larger network, responding to signals that were abstract as well as physical. Yet, even with this added influence, the heart remained largely independent. It did not wait for conscious thought. It did not require attention. It continued its rhythm even when awareness faded. This balance between responsiveness and autonomy is one of the heart's most remarkable evolutionary achievements. The heart listens, but it does not surrender control. As emotional complexity increased, the heart learned to respond to patterns of feeling that unfolded over time. Prolonged stress altered rhythm. Extended calm softened it. These changes were gradual, not sudden, reflecting the heart's preference for stability. This stability protected the body from extremes. If every thought dramatically altered heart rhythm, the system would be chaotic. Evolution favored hearts that responded proportionally, adjusting gently rather than reacting sharply. This is why heart rhythm varies naturally rather than remaining perfectly steady. Small variations reflect adaptability. They show that the heart is listening, not rigid. A heart that can change slightly from moment to moment is better prepared to handle what comes next. As human societies became more complex, daily life began to include longer periods of stillness, planning, and anticipation. The heart adapted by becoming efficient at low levels of activity, conserving energy without losing readiness. It learned how to wait. Waiting, for the heart, is not idleness. It is poised stillness, a state where output is reduced, but responsiveness remains intact. This allowed humans to sit, observe, plan, and communicate without exhausting their bodies. The heart supported this shift quietly. It slowed when movement was minimal. It accelerated smoothly when action was required. It maintained circulation through long periods of thought and social interaction. In doing so, it helped shape a species capable of reflection, cooperation, and foresight. And yet, despite this deep integration with the nervous system, the heart never lost its original role. It continued to prioritize rhythm over speed, consistency over force. It remained an ancient organ supporting a modern mind. In the next part, we'll explore how this ancient system continues to function in the modern world, how a heart shaped by long walks and open landscapes responds to stillness, stress, and routines very different from those it originally evolved to support. As the world changed around humans, the heart carried its ancient design forward into unfamiliar conditions. For most of its evolutionary history, the heart supported lives shaped by movement and variation, walking long distances, resting deeply, responding to natural rhythms of light, temperature, and season. Activity and recovery followed one another naturally, without being scheduled or forced. Modern life altered that rhythm. Stillness became prolonged. Movement became optional. Stress became less physical and more abstract. The heart did not evolve for screens, deadlines, or constant anticipation. Yet it adapted, the way it always has, by continuing to respond to signals it receives. This adaptation is quiet. When the body remains still for long periods, the heart slows its baseline rhythm. It conserves energy, assuming movement will return soon. When stress arises without physical action, the heart responds cautiously, increasing pace, but not releasing that energy through movement. This creates a new pattern. The heart prepares for effort that does not arrive. It becomes alert, then waits. Over time, this waiting changes how rhythm feels. Not unstable, but less resolved. The heart is doing exactly what it evolved to do, responding to signals honestly, even when the environment has changed. What's important to understand is that this is not failure. It is continuity. The heart does not judge the modern world. It does not expect the past to return. It simply applies ancient rules to new circumstances. It adjusts output. It conserves when possible. It responds when needed. Even in long periods of sitting, the heart keeps blood moving. It maintains pressure. It supports the brain's demand for constant supply. It does this without complaint, without fatigue, hour after hour. At the same time, it remains sensitive. Small movements still matter. A change in posture, a brief walk, a stretch. These signals are immediately recognized. The heart responds by increasing flow, redistributing blood, and reestablishing rhythm. This responsiveness shows how little it takes to engage the heart's evolutionary strengths. The heart does not require extremes. It responds to variation. Throughout human history, variation was constant. Different terrains, changing weather, shifts between effort and rest. Modern life reduced this variation, but the heart remains prepared for it. It listens for change. This is why the heart often feels calmer after gentle movement, even without conscious intention. The system recognizes familiar patterns. Movement signals safety. It tells the heart that energy can be spent and recovered naturally. At the same time, modern emotional stress introduces signals the heart has had to learn to interpret: concerns about the future, social pressures, mental effort without physical release. The heart responds, but it responds cautiously, maintaining readiness without exhausting itself. This balancing act is ongoing. The heart continues to support long hours of thought, focus, and anticipation, just as it once supported long walks and watchful nights. It adapts its rhythm to whatever environment the body inhabits. What remains unchanged is its commitment to continuity. It does not seek optimal conditions. It seeks stability across conditions. As a result, the modern human heart is both ancient and current at the same time. It carries rhythms shaped by evolution, operating within environments evolution never predicted. And yet, it continues. In the next part, we'll look more closely at rhythm itself, how the heart's beat became more than repetition, how variability became a sign of health, and how subtle changes in timing reflect the heart's deep evolutionary intelligence. As the heart continued its long journey through changing environments, rhythm itself became one of its most important tools. At first, rhythm was simple repetition, a squeeze, a release, again and again. Consistency mattered more than anything else. A heart that kept going was better than one that occasionally worked harder. But over time, evolution discovered something more subtle. Perfect regularity was not ideal. A heart that beat with tiny variations between each beat proved more adaptable. These small changes allowed the heart to respond smoothly to shifting demands, to adjust without strain, to remain flexible rather than rigid. This variability did not weaken rhythm. It refined it. Each beat still followed the same pattern, but the space between beats could stretch or shorten slightly. This gave the heart room to respond to breath, movement, posture, and internal state without losing coherence. This flexibility became especially important as nervous systems grew more complex. Signals from the body and brain did not arrive all at once. They came in waves. Some were brief, others lingered. A heart that could very gently was better able to integrate these signals without overreacting. In this way, rhythm became communication. The heart was no longer just repeating a pattern. It was listening and responding moment by moment while maintaining its core stability. This balance between order and flexibility is one of the heart's deepest evolutionary strengths. It mirrors something seen throughout biology. Systems that survive longest are not the most rigid. They are the ones that can bend without breaking. The heart embodies this principle with every beat. As humans developed richer emotional lives, this flexibility became even more important. Emotional states change quickly. Anticipation rises and falls. Calm appears and fades. The heart's ability to reflect these changes subtly allowed the body to remain balanced through emotional shifts. A slightly faster rhythm during alertness, a softer rhythm during rest, a gentle variation that never loses its center. This adaptability protected the heart from exhaustion. Rather than swinging sharply between extremes, it learned to move within a range. This reduced wear over a lifetime and supported long-term survival, not just short-term performance. Even during sleep, this rhythm continued its quiet conversation with the body. Breath slowed, muscles released, signals softened. The heart responded by easing its pace, increasing variability, allowing deeper recovery. It did not stop listening simply because consciousness faded. This nighttime rhythm became an essential part of the heart's evolutionary role. Sleep offered a space where repair could occur, where the heart could operate at lower demand, conserving energy while maintaining circulation. Over generations, hearts that supported deep rest contributed to healthier, more resilient bodies. This is why rhythm changes between day and night are so deeply ingrained. They are not habits. They are heritage. The human heart carries patterns shaped by countless nights of rest and countless days of movement. It knows how to shift between them without instruction. It has practiced this transition for millions of years. Even now, in the modern world, these rhythms persist. The heart still responds to quiet evenings. It still eases during stillness. It still prepares gently for rest. When conditions allow, it returns to patterns older than language, older than culture, older than memory. And as this ancient rhythm continues, it shapes not only circulation, but the entire experience of being alive. The sense of pacing, the feeling of balance, the ability to recover after effort. In the final part of this journey, we'll step back and look at the heart as it exists today, not as a problem to solve or a machine to optimize, but as an ancient companion, one that has carried life forward patiently, adapting again and again, and still doing its quiet work without asking for attention. As we come closer to the present moment, the heart stands exactly where it has always stood, not at the center of attention, but at the center of continuity. The modern human heart is not a new invention. It is the same ancient structure that learned to move fluid through soft bodies, that divided itself slowly into chambers, that perfected rhythm long before thought existed. It now beats inside a world very different from the one it evolved in, yet it follows the same principles that have always kept life going. It responds, it adapts, it continues. Every heartbeat today carries layers of history, echoes of oceans where circulation first emerged. Traces of long migrations across land, patterns shaped by rest, movement, danger, safety, and recovery. None of this is remembered consciously, but all of it is present in structure and rhythm. The heart does not rush to meet the modern world. It meets it steadily. When life becomes busy, the heart adjusts. When life becomes quiet, it softens. When the body sleeps, it continues its work without interruption. This constancy is not rigid, it is patient. The heart does not demand ideal conditions. It has never needed them. It evolved through uncertainty, variation, and change. It learned how to keep life moving forward even when environments shifted, resources changed, and rhythms were disrupted. That learning is still active. Inside each person, the heart quietly balances ancient expectations with present reality. It listens to signals from the body and nervous system. It integrates them gently. It avoids extremes when possible. It favors rhythm over intensity, consistency over force. This preference is deeply evolutionary. Life persisted not because hearts were powerful, but because they were reliable. Not because they reacted quickly, but because they recovered well. Not because they optimized every moment, but because they endured across time. The human heart is an organ of endurance. It supports long days and quiet nights. It sustains effort and allows rest. It works without instruction, without praise, without needing to be noticed. Even now, as you listen, it continues its rhythm, shaped by millions of years of adaptation. There is something grounding in that. The heart does not belong to urgency. It belongs to time. It measures life not in achievements, but in continuity. Beat after beat, cycle after cycle, carrying what is needed, releasing what is not, adjusting without drama. And as this long evolutionary story settles, it leaves behind a quiet perspective. The heart is not something to control or perfect. It is something that has already learned how to persist. It has carried life through darkness and light, through stillness and movement, through worlds that no longer exist and moments that are still unfolding. It continues now, just as it always has. Steady, adaptive, uninterrupted. And that rhythm, ancient and ongoing, remains one of the simplest and most enduring signs of life itself. As the story of the heart stretches beyond structure and rhythm, it begins to touch something quieter. Presence. The heart has always worked in the background. It does not announce its effort. It does not draw attention to its endurance. Most of the time, it goes unnoticed, even as it supports every thought, every movement, every moment of rest. This invisibility is part of its success. Throughout evolution, organs that demanded attention were liabilities. Pain, urgency, and noise were signals of failure. The heart evolved in the opposite direction. It became something that could work continuously without calling for awareness. In early life forms, this invisibility allowed organisms to focus on their environment rather than their own internal mechanics. As animals grew more complex, it allowed attention to shift toward movement, perception, and eventually thought. By the time humans appeared, the heart had perfected this role. It did not compete with the brain. It supported it. This relationship shaped human experience in subtle ways. Because the heart could be trusted to continue, awareness was free to wander. Memory could form. Imagination could unfold. Long periods of reflection became possible because circulation remained steady beneath them. The heart made inner life possible by staying out of the way. Even emotional experience depends on this reliability. Joy, fear, curiosity, and calm all require a stable physical foundation. The heart provides that foundation quietly, adjusting its rhythm to support each state without dominating it. This is why the heart feels most present when something is wrong, and almost absent when everything is working as it should. From an evolutionary perspective, this absence is a success. The heart learned to integrate itself so fully into the body's systems that it became background rather than foreground. Its rhythm blended into the fabric of experience. Life did not need to stop to notice it. As human cultures developed, the heart took on symbolic meaning. It became associated with emotion, courage, and connection. But these meanings came long after the heart had already done its evolutionary work. The organ itself remained unchanged by symbolism. It continued to do what it had always done: respond to signals, maintain flow, preserve continuity. Even in moments of stillness, when the body is quiet and the mind drifts, the heart remains active. It marks time without measuring it. It carries the present forward without asking what comes next. This constancy offers something subtle but important. It anchors awareness. When everything else changes, the heart's rhythm remains familiar. It becomes a reference point the body can return to, not consciously, but instinctively. A reminder that something steady is always happening beneath experience. In this way, the heart connects moments that feel separate. It links waking and sleeping, effort and rest, thought and sensation. It does this without narrative or memory, purely through rhythm. Evolution favored this simplicity. Complex solutions break. Simple ones persist. The heart is a simple solution refined endlessly. It did not become complicated by choice. It became reliable by repetition. Over millions of years, beat after beat, it learned how to keep life moving forward without interruption. And that learning is still active now. In the next part, we'll widen the view even further. We'll step back from biology and look at what the long evolution of the heart teaches about time, patience, and the quiet ways life sustains itself without urgency or control. When you look at the heart through the long lens of evolution, something gentle becomes clear. Change did not come through force. It came through patience. The heart did not leap from simplicity to complexity. It moved step by step, adapting only when adaptation was necessary. Each version worked well enough to carry life forward, and that was always enough. This is how life persists. Evolution is often imagined as struggle, competition, and survival. But the story of the heart reveals another side, one shaped by continuity, by solutions that last because they are quiet, not because they are dramatic. The heart evolved to do the same thing again and again, without becoming rigid, to repeat without stagnating, to adjust without losing itself. This balance between repetition and flexibility is rare. Too much repetition leads to fragility. Too much change leads to instability. The heart found the middle path. It learned how to respond to what is present, not what is ideal. When bodies grew larger, it adapted. When environments cooled, it refined its efficiency. When nervous systems became complex, it learned to listen without surrendering control. It never tried to predict the future. It responded to the present. This approach shaped the kind of lives humans could live, lives that unfold over decades, lives that include effort, rest, learning, forgetting, connection, and solitude. The heart supported all of it by refusing to rush. It did not demand perfection from the body. It did not require constant optimization. It simply continued. This perspective matters in the modern world. Today, there is pressure to improve everything, to monitor, measure, optimize, and control. The heart stands quietly outside of this urgency. It reminds the body that persistence matters more than intensity, and recovery matters as much as effort. The heart does not hurry toward outcomes. It moves at the pace of life itself. Over millions of years, this pacing allowed life to diversify, stabilize, and endure. The heart became a keeper of rhythm rather than a driver of speed. It held space for change to happen gradually, without collapse. There is something deeply calming in that realization. Inside every person, the heart carries a memory older than thought. A memory of slow progress, of steady movement, of survival through balance rather than force. This memory does not appear as images or stories. It appears as rhythm. Beat by beat, the heart reflects an ancient agreement with time. That life unfolds at its own pace. That rushing is not required. That continuity is enough. As you listen to this story, that rhythm continues quietly, doing what it has always done. Supporting awareness without demanding it. Carrying the present moment forward without asking where it leads. In the final part of this journey, we'll allow the story to settle. Not with conclusions or lessons, but with a wider sense of perspective. A sense of how the heart's long evolution mirrors something deeper about life itself. As the story of the heart reaches its quiet end, nothing truly finishes. That is perhaps the most honest reflection of what the heart represents. From its earliest beginnings as a simple movement of fluid, to its place now inside the human chest, the heart has never been about arrival. It has always been about continuation. About carrying life from one moment to the next without asking for meaning or recognition. The long evolution of the human heart is not a story of progress toward perfection. It is a story of learning how to last. Across oceans and continents, through cold and warmth, through danger and rest, the heart adjusted just enough to remain reliable. It did not chase speed. It did not seek intensity. It learned how to repeat itself without wearing down. That learning lives on. Inside every person, the heart continues its ancient work. It moves blood through pathways shaped by millions of years of adaptation. It responds to movement and stillness, to effort and rest, to waking and sleeping, all without instruction. It does not know the future. It does not remember the past. It exists entirely in rhythm. And yet, that rhythm carries everything else forward. Thoughts rise and fall. Emotions come and go. Days begin and end. The heart remains, steady beneath it all, shaping time not in hours or years, but in cycles that repeat quietly. This is why the heart has always felt symbolic, even before symbols existed. It represents persistence without struggle, change without urgency, life continuing without needing to be noticed. The heart does not demand attention to do its work well. It thrives when allowed to remain in the background, trusted to carry on. In this way, it mirrors many of the systems that sustain life quietly, without force. As this story settles, there is nothing to remember and nothing to apply. The heart does not ask to be understood in order to function. It has already learned what it needs through time itself. It will continue after this moment. It continued before it. It will carry the next one gently into place. And as awareness softens and the day fades, that rhythm remains. Ancient, patient, uninterrupted, still doing what it has always done, moving life forward, one beat at a time.